All yours.
Okay. Hey everyone. I'm here to talk about what we have been doing at Expedia, which mostly about Docker. Right? I'm not going to talk about our entire cloud journey here. What we have been specifically doing around Docker, and what we are using right now in AWS. Again, we could talk all night or maybe tomorrow about different things that we had to go through when we are doing this journey. So we'll focus more about how we have enabled our teams within Expedia to consume or use Docker, right? We could do another meetup talk about how do we manage our clusters in AWS, how do we maintain them. So we will follow up if someone has an interest, we can do a follow-up session around it. But today's talk is more geared towards how did we enable our developers to use Docker at Expedia. And I'm Kuldeep, Chowhan, I'm a principal engineer at Expedia. I've been with Expedia for more than 4.5 years now. And for more than 4 years, I've been working in building tools around how do we let our teams use different AWS services. Again, my talk is around Docker running in AWS. Just to be clear, nothing on data center, more on AWS. We have also Suresh, Mamidi from Expedia. He's also going to talk about a few things after. I will cover the initial part of it, Suresh will cover the rest of it. Again, as I mentioned, what did we build, and then how does people deploy to AWS, and then the automation that we build, and different types of blue-green deployments. We call it as canary, but the concept behind the scenes is basically blue-green deploy. And then, if time permits, we'll do it in also. Our footprint in AWS, we are in 5 different AWS regions, and our journey started more than 5 years ago. Right? Like 5 years ago, again, we have our own data centers that are in Arizona, 2 data centers that we have. Initially, when we were using AWS, it was not a migration as such. It's there it is. We try to build microservices. How do we go and deploy our services there? Basically, do a test and learn, right? Like how does this will play with what we have in our data center? So we had few services over the course of first 2-3 years, probably like 12 services running in production, getting production traffic. In 2014, we built something called as Primer. I'm going to talk about it later on, but that helped our adoption significantly, AWS. And we are right now at least looking at migrating off of our data centers and see to put most of our services in AWS. I'm not going to talk about the benefits of AWS or public cloud. They are using AWS at this point and leveraging different aspects that are available in AWS. So we are in 5 regions, spread across the globe, trying to be close to our customers. We have about 75 different points of sales across 60 different countries. So it's not only just we cater to North America, but we cater to APAC and European markets as well. So we have more than 20 VPCs that we run across all these different regions. And to connect to our data center, we do use Direct Connect. So earlier I mentioned that the talk is more about what we do, what we consume. So to run our Docker containers within AWS, we chose ECS. Right? We started probably more than 2 years ago when ECS came up. At the same time, we were also looking at, how do we move from deploying our services to CloudFormation, like EC2 instances use CloudFormation and auto scaling and do all that stuff. We were doing it, but we were also trying to see how do we leverage Docker, how do we deploy our apps as Docker services within AWS. At the same time, ECS came up, so we started building our automation to work with ECS. We had growing pains, if you will, not pain, but growing pains, and we worked very closely with ECS team to give them the feedback that was required, and they were also definitely, we actually talked to them once a month, give them the feedback. Some of this feedback goes into their products and then it comes back, right? As I said, we can talk another session about our cluster management and all the growing pains and what all the different tool sets that we built around it. Again, the reason in general I just talk about Expedia is a travel company, and we are in the business of writing software to help people travel. Like, we are not here to manage Kubernetes clusters or ECS clusters. We are trying to write software. And with ECS, we do get the benefits of someone managing the clusters for us, someone managing the masters for us. We worry about how do we schedule our apps, how do we place our apps, create the clusters. There are a few things that were missing on ECS, like the cluster upgrades, zero downtime cluster upgrades that we had to build. But as such, we didn't want to go through that pain of running our own setup and then having to manage the infrastructure ourselves. And then a lot of benefits that you get with ECS, like you can use the IAM that they had, using the load balancer. But there are different load balancer options that are available now, application load balancer, but we are heavily scaling the elastic load balancer ELTs. And over time, I think a lot of features have been added with ECS, like flexible container placement, trying to match what Kubernetes also offer, right? Like you can have attributes to say which AG to go and whatnot. But for us, it was the ease of spinning up a cluster and having someone managing it for us, and then leveraging some of the existing AWS services. That was the reason why we chose ECS. Again, footprint-wise, we have 4 different clusters across the globe. When I say cluster here, a cluster it doesn't make up like by 2 boxes or 3 boxes. Some of the clusters are more than 100 nodes, like C4, 4 extra large, or R3, 8 extra large boxes, not a small, tiny to medium boxes. I believe we were the first service to actually break ECS limit of more than 500 services per cluster. So the way that we were operating is 1 cluster per environment per region. That was our setup. So all the new apps that were actually getting deployed to AWS or ECS, we were stuffing all of them into 1 cluster. Cluster became big. The number of services that actually went in also were, I think we reached more than 500. Now I believe we are more than 1,000. Maybe 750 or around 850 services, like ECS services, if you will, are Kubernetes services for people who understand Kubernetes, running within a cluster. So we have 12, we have more than 700 actual EC2 instances that are behind this 12 clusters. So we have about, looks like across the board, both test and prod, we have over 2,600 services. These are all microservices, small microservices. These are again test and prod together, right? Containers wise, it's more than 11,000 containers that we run across all these clusters that we have. This is prod only. The one that I showed is both test and prod. This is just prod, same metrics. 90 clusters, 500 instances. Services are like 1,200 different microservices that are running within these clusters. We use load balancer. We don't have any service discovery using console or some other. We natively are using load balancer and basically use load balancer with DNS being our service discovery, right? Like using Node 53's capabilities and then load balancer, load balancing, we just use those as our service discovery. Of all these 1,200 apps that I talk, small microservices, we process about 600 million requests a day. Again, this is only prod, I'm not talking about test. About 600 million requests a day by all these services that we have. I'm going to talk about primary in a minute, but like all these 1,200 apps that we have, how many times we actually deploy a day? We about, looks like we are doing about 850 deployments per day with ECS every day. It's all automated. No one can manually deploy 500. I don't know if you can, but it's all automated. So we do about 550 deployments a day. ECS. Again, I'm going to talk about primer. Just give us a brief history. As I said, we actually started about 5 years ago. For the first 2 years, we started with infrastructure as a code model. We started using Chef. And then we also built internally some libraries to facilitate the microservice architecture, because they break apart into multiple services. How do you tie them together? not everyone has to repeat the same code, like our sites like Expedia.com, Expedia.co.uk. So a lot of those form things that we built all those. And deployments were, I would say, self-service, but every team had to go through writing a chef code. Every team had to create the infrastructure as a code. Every Java app had to wire all these libraries that I talked, like platform side, platform content. So there was some learning curve. Right? Some teams were able to do it in a week, some teams in a day, some teams maybe a month. But everyone had to do the same thing, right? So what we did in 2014, we called it as primary internally within Expedia, where the approach that we take is we come up with a template that has everything that I thought. Basically a Java app example. What we built was a Tomcat app. We created a Springboot Java app with like the platform libraries built added to it. Automatically create a chef, like a platform cookbook, chef cookbook that would go and deploy this service to AWS. And then build monitoring using, like I think at that time we built using Graphene. So our data store for monitoring was Graphite. To put a dashboard on top of it, we used Graphene. So we built a template dashboard for each set of app using Graphene. And the intention, we did this like in a month, basically in 2014. Not this thing, but was using Jenkins, a plain old shell script. So the intention was within a month, like by the time we are done, teams would go to a Jenkins instance and say, I have an idea. Example, let's say Meetup, Docker Meetup is the app name that I want to build. And select that template, and everything that I talked, chef cookbook and all that stuff, are all built for them automatically. Basically a templated approach. And that's how we started our adoption. So, and now, as I showed you earlier, we have probably right now, when I looked at the dashboard, more than 4,000 apps have been, microservices or apps, if you will, have been created within Expedia. And a lot of, it's a journey for us, right? Like we started with 2014 with the Jenkins instance. Now, this is a React.js app, the one that I'm showing. It's a full-blown platform internally. There's a lot of services behind the scenes. Very high level, this is what Primer does for everyone, the things that I taught. But this is talking about how we are doing for a Docker-based app or ECS-based app that gets deployed. So the user goes to the site. Again, if time permits, Suresh will do a demo as well. So people go to your site, they enter, hey, what is the name that they want? We use GitHub internally, GitHub Enterprise within our firewall. And then we create these templated source code repos. We support about 37 different types today. You name it, probably we already have a template for it, which that template already has a Docker file that talks about, it already has a Docker file using the same approach that we take. Like a Node.js app already has a Docker image built for it. And a Java app, sorry, Springboot Java app already has one. So I'll show it in a minute, we'll have more clarity about it. And then we use Jenkins to do our CI/CD. So it goes and creates different Jenkins jobs within our Jenkins instances so that like you can target a master branch or all the branches. And then master is trying to do a full CI/CD where every check-in that you make to master automatically goes to test environment in AWS on ECS. You can write it in where you can change it so that it can go to prod as well. But it's up to the teams. We provide them the tools. It's up to the teams to figure out how they want to roll it out. And then we use Splunk for our log management. So the Docker image that was like the base Docker image that I talked earlier has already this Splunk config. The app is already pre-wired to write in a particular file structure so that Splunk automatically picks it up. And then we use for different ones like Java, we have a library to push the JMX contours out to Graphite. Similarly, for each one of the templates, we have different things. The notifications wise, we use the chat, we have email, we are starting to use Slack as well. But the approach that here we follow is something called as minions using Amazon, AWS or Amazon, I don't know, but Lambdas. basically you can plug in different adapters here. Tomorrow if you are using maybe something else, you can plug in that, and then you can send your notifications to your favorite chat channel, whatever it is. Very high level, these are different types of templates that we support: Java, Node, Spark, PHP. I don't know if anyone is creating a PHP app, but majority of them are either Node apps or Java apps. Even in Java, it's Spring MVCs, Springboot, etc. There's few apps that I think still are running as Ruby, Rails, not very Sinatra apps. So Suresh will go through the CI/CD setup, and based on the time, he will probably do a demo as well.
Okay. So yeah, I'll talk about the CI/CD portion of how an application gets built and deployed into Amazon ECS. This chart is similar to the app creation one, but more focused towards the CI/CD side of the things. So as Kuldeep already mentioned, when the primary application gets created, we create a GitHub repository already pre-built with like starting from a base Docker file to all the folder structures that are needed for them to start writing the code, the software themselves based on the business logic. So what happens when a developer checks in, or an application checks in a code to his application repository is that we use GitHub webhooks in order to achieve the CI portion of it. And what it does is it triggers a Jenkins build, which once again the Jenkins job would have already been created by the primer when an application gets created. So the build job basically gets triggered. All it does is it builds the application and it pushes the resultant documents to the Docker-registry. We use Docker-registry. We host it internally. Docker-registry, and we push all of our application images into the Docker repositories within the Docker-registry. Okay, I'll show the individual components in detail, and if demo probably, if we can make it, we can see that as well. And then for the CD portion of it, once again, we rely heavily on Jenkins. So we have Jenkins job to actually deploy and release the apps. So we actually make a distinction between the deploy and release just so that people have a chance to smoke test their applications, do a certain sort of load testing, stress testing, whatever that is needed before actually doing the cutover. And we got automation written in Ruby to support the deployments and releases. So the way that the application gets deployed in ECS is we create a bunch of AWS resources in order to make up an application stack. So starting with the service that gets created in the Amazon ECS itself, which runs the actual application containers, and we also provide friendly CNAME using for the app using Amazon Node 53, and we also use SNS and Lambda to achieve the notification to the channels of the user's choice, basically. And a bunch of this configuration on how an app gets deployed is basically stored as a configuration files in the application repository itself. Probably go over the configuration that we offer if we have time, so that people can mention, hey, these are the minimum number of instances that need to run for my application, and this is the max that needs to run, and this is how I would configure my auto-scaling. ECS offers an application auto-scaling that we can configure it when creation or when we update it. So all those tweaks for the application can be made by our configuration files that once again get stored in the configuration in the application repository itself. So I'll talk about the individual components basically, and before going into the demo. As I said, we use the Docker-registry hosted internally, and we have repositories created for each application, and we store the tags. So we store the application versions using we actually use the GitHub shard to actually version the application itself. So And the other important thing that I wanted to mention is when I talked about the build job here in Jenkins. So, in Jenkins, it actually uses the open source Jenkins Docker plugin in order to build and publish the Docker image to the Docker-registry. So directly just configure the plugin within the build job so that it takes care of the build and publish commands. And just to give you an overview of what comprises of, what does the Docker image consist of when I say, when I talk about Spring MVC or Web MVC or Express.js Node app. This is what I kind of grabbed it from one of the templates that we got. This is the base. This is coming from the base Docker image for the Node.js template, primer template. So we do a bunch of initialization and make it ready for the applications to start running right away, so that they can focus more on the application logic. So we do a bunch of init in order to avoid the PID1 issues, and then we set the working like we set a bunch of environment variables, and we set up the Docker entry point, and we do the npm install, what is all that is needed for the application to start, and then we do the npm start at the end. So right off the shelf, when we create an primer application, an application using primer, the application is ready to run basically, and you just need to add extra logic, whatever you want within the application repository. And this is the Docker file that an application actually receives when it gets created. So the one that I showed before is the template, the base template. But when you create an actual application, it just uses whatever the base image that is there, and people can override custom things, whatever they want. They can even add extensions to the Docker entry point to support that too. So people can still override anything that they want in the actual application repository, but we start with the base template. And then next I wanted to talk about the actual the blue-green kind of the deployment, how we actually deploy and release our applications. The way that we actually do the CD and release your versions of the application is that we use a concept called Canary application, where what we do is when someone triggers the actual deployment job, what we do is we create a separate application stack, this entire application stack basically, and prefix it with Canary hyphen in order to just distinguish the real application from the Canary. And people can, the teams who build the application can actually use that stack to do that load testing. And then we have a separate release job to actually do the cutover from the Canary to the real service. So the way that we actually do the release using ECS is this basically. Let's say an application stack has an ELB and it has 2 containers running on our ECS cluster with the version v1, and then it wants to deploy or release a newer version of the application. So what we do is we create an entirely different Canary ELB stack, and we just default it to 1 container so that you can just smoke test that application. And what we do is we then make an AWS ECS call when we do the actual release to update the service in place into the V2 version basically. Just a single API call that we need to do, that's the advantage that we get. So when we do the actual update service on the ECS, what it does behind the scenes is that it creates a newer version of the container once again, depending on how much min count or max count that is needed. And in this illustration, I'm just assuming that they have the same number of containers. And what we do is, and what ECS does is it just switches the ELB to the, so it just adds the newer version of the containers to behind the ELB and then drops the further instances basically. And then we do a cleanup after ourselves to clean up the Canary ELB stack as well. So that is the deploy and the release side of the things. Okay, I think I quickly close through the slide that I want to talk about. I think I can take demo already. So 7:30, so it's going to take maybe 10 minutes-ish, 5-10 minutes. Feel free to ask any questions meanwhile, but I will start to show what Kuldeep and I was talking about. So this is the primary UI that we have internally. Okay. So this is the primary homepage, and so we were saying we have already close to 4,000 apps that are already running. Let me go ahead and create a new application. A bunch of other things as well, but I'm going to go ahead and create the application. Let me choose the Express.js.json because that's the one I talked about. We also mandate few some information that we need when an application gets created, so that we can associate what team is using it, and when we expose the cost and all expenditure in terms of who is using what and all, and also to assign the ownership and of what team or what line of business and is using this app. So. This is the team email, but for now I'll give my own email. So we also require what portfolio that you need. I'll just choose something. And we need the product as well. Let's choose something for this purpose. So we also, as I said, we can send notifications to the various channels that we need. Right now, we kind of ask a picture group, and going forward, I think we're going to add custom channels as well on the UI itself. Let's give something that I want. And these are like some other information that we need. So we have basically for production we have two distinction basically. If it is a PCI app, we deploy to a secure PCI environment. If not, we have a regular prod environment. Let's click submit. So the timer now shows what are all the steps that it takes in order to complete my application creation. This will take a couple of minutes, not more.
Do you have a PCI set of app choices in Primer?
Sorry?
For PCI, do you have a set of app choices as well?
I don't
So
know if
it's more than an app, it is the environment that it goes in.
Right, I know it's both actually, so that's why I'm asking.
So it's not about, like in the previous screen, you saw an option about prod and prod B. So prod B is an environment or a zone that we have in AWS.
Understood.
That is PCI.
Yes.
So if someone wants to go and deploy there, they can go there.
Right. I was asking a separate question, which is, you could set up templates to assist the developers in building PCI, apps that will, comply as part of the environment. And just the fact that the environment's PCI compliant doesn't mean that the entire app is. So.
Yeah. So our take on that is it's not about whether the app goes into PCI that makes it PCI.
Oh, right.
We run all the required things across all the environments. So we're not talking about, hey, this app that we are going to build is going to be only in this zone versus, like, I get your question, right? But we are not treating that way. We want all the things that a PCI app needs to be handled by all different apps in even non-PCI environments as well. Because some of the restrictions are, like, example, I'm saying, like intrusion detection service, example, it's an environment specific. Versus the application passing all your static code analysis.
I'll follow up after.
Yeah.
I'll follow up after. Thank you.
Sure.
So, yeah, so as you can see, this is what Mamidi is doing. So first checked whether the application already exists, if not, it created it, and then it created the GitHub project that is needed. I'm going to go over all the, I'm going to show all the details later, and then I created the Docker repository, which is the Docker clusters registry, and it registers with the 45 for the static code analysis, and then it created the build job, and we also run 45 scans using Jenkins. So we created that too. I think so we actually created two kinds of build jobs: one to build master and one to build one to run the build upon checking into any branch, so that people can just trigger the build and see the build works. So that's more of a convenience to have two build jobs. One is called master and one is called all. And then it also increased the creation by sending the notifications to the email ID that I configured. So now I'm going to go to the application details. This is the home page of an application. It gives all the information about the application, what we entered, as well as some other information like we made the apps based on different parameters, so that people are encouraged to calculate all the information. So the first thing I want to show is the application repository that gets created. So this is what I got for my app basically that I just created. So it has already stuff pre-populated, and I will set the Docker file contents. If I want to inspect, this will be directly using the base template. And the other interesting thing here that I wanted to go over is the configurations that we offer. So this is where the application teams can configure what are all the settings that they want for their application to run. So there are a bunch of global settings like whether you want HTTP enabled, HTTPS enabled, and all the other information that is entered during creation. It can be customizable as well, and notification details and everything. So this is about the application itself, and then let me show you the build job that I talked about, so that we can start demonstrating how we actually build and deploy. So let me take this app name, show you the build job that we have. So
Miss the V at the beginning.
sorry.
Miss the V at the beginning.
Oh, thank you. Yeah, but luckily Jenkins found it for me. Okay, so that's the master job. I'm gonna So I'll just quickly show you what this Jenkins job actually has. Mainly I wanted to show you the built-in publish Docker plugin, which is what I was talking about. We directly use the built-in Docker plugin in order to push the image to the Docker cluster registry, which is repository. You should be able to view the repository for my app that just created. Right now I haven't pushed anything yet because I haven't built my app at least, so you won't see anything, any versions of my app just yet. So let me go ahead and trigger this job. So it actually builds and publishes the application to the Docker cluster registry. And meanwhile it gets built, I think we also have like few other information, few other tabs on the application homepage on Primer. One of the important ones is the pipeline, which actually gives the a complete overview of the CI/CD pipeline. Maybe I need to figure it just one run. Oh, yeah. So this is how the application pipeline looks like. So the build job that we triggered and then followed by the deployment to the test environment, that's the default step, and Polyverse scan of course, and followed by the deployments to the other environment. So people can configure this pipeline in however way that they want, so that they have the flexibility to deploying their application into their environments. Also introduce any steps that they want in the middle.
And everyone gets this without them having to do anything. If they want to configure, they configure it, but they get all this with just that one push of a button that we talked earlier.
So the build job completed, so it built and published my Docker image. As you can see, it's all good. So if you go and just verify here, it should have the latest whatever SHA that we built the application with. So that will be that completes the build step. Now coming to the deployment, so we rely on the Jenkins once again. So that we quickly deploy to an environment. Just use the it's manually there. So let's see. Oh, nice. So as a part of the pipeline, the other thing that what we do is we by default deploy the application to a test environment. People can once again override if they don't want it in their configuration. But so I don't need to trigger the deployment, but the primer actually did that for me. So as I said, we create a bunch of the application resources, starting with the ELB, ECS service, and also a friendly CDN. So I'll wait for this to get finished. But once it is finished, maybe in the interest of the time, I can just show you what an application looks like. This is a sample application that we already created, and by default, we make the application respond on the build info, which gives the SHA basically which it is running. So I just get a build info from there. Basically shows up like this.
And even the CNAME pattern, we specifically put the region in it, the environment in it. Right? So again, as I said earlier, the service discovery for us is Route 53 plus load balancers. We don't have any console or any other place where we go and register these things. So every app uses that, and we encourage teams to not use fully qualified domain names. Just say within your environment, talk to shopping cart UI or shopping cart service. And with the DNS settings that we have already set up, people automatically go to that app within that region.
Cool. That's mainly what I want to talk about. Yeah. If you have any questions, you can ask now, or
If you want us to show like anything else specifically, we can do that as well.
yeah.
It's up to you. 5 more minutes.
Yeah. I was thinking of showing the AWS console and the services and the other stuff, but
We can be here all
for
night.
questions, but
Do you have a metrics dashboard?
and what?
A metrics dashboard?
For which one? For the application.
Show how many containers are active, how many microservices are active, failures, restarts, resource usage.
So some of them we rely on ECS. We actually open source a tool called as C3base, which I think the link is there in the it's on our open. The idea with that is, if you select a cluster, it will show all the instances, the EC2 instances that are behind the cluster, and it shows the CPU and memory utilization per container. And some of the other things we just use CloudWatch. Right? Like CloudWatch provides a lot of metrics for us. We didn't have to build other dashboards ourselves. And each app again has its own dashboards. Earlier we used to use Graphene, today we use Grafana, powered with Graphite. Graphite is our data store which stores all our metrics, and then we use Grafana. Yes?
When you chose ECS, were you concerned at all about being locked into a single cloud provider?
We are in AWS. So in a way we are all ready, right?
Right.
So it's not about whether we are logged in. Our goal, at least right now, is to migrate from our data centers right? Be close to our customers, have more resiliency around our services. That's our main goal, right? What we are doing today, we might do it after maybe 10 years. I'm just going in, right? For now, the goal is use AWS, migrate your apps. We do operate very well in AWS. That's at least our goal right now. Yes.
Is there any plan to open source Primer?
Yes, we have been trying to, but a lot of the things that we showed has evolved from being a Jenkins and a shell script. So we have been building all those building blocks that can enable us to better, like plug in whatever you want. Today we are doing GitHub Enterprise. Not everyone would use GitHub Enterprise. Someone would use Stash or something. So we are trying to build those building blocks and then look at open source. Yes.
Your communication with AWS, is it direct calls or is it something like Terraform in between to enable the containers?
So the automation that we are talking about in the ECS one specifically was like homegrown completely even before CloudFormation supported ECS. So a lot of the stuff that we are talking are pure Ruby scripts that are interacting directly with ECS. So one day we want to move to CloudFormation because we have another stack that gets deployed to EC2 using autoscaling and whatnot. Use CloudFormation, but right now it is very custom Ruby code. Yes.
Do you do aggregation or chargeback by metering so you can see where the usage is happening?
That's the feedback that we have been actually giving back to ECS so that they can provide that out of the box for like how much it is going to charge, right? But we did build tools internally looking at CloudWatch. In Ramon Chart, I could have shown it. I don't know where it is. So we actually do that on the fly. It's not that if the team wants to do it, they can do it. We can provide those metrics back. But unfortunately, right now, the way that ECS is being shown up in our billing is it's a shared resource. A shared resource across the globe, like it was or ideally, yes, but we have those tools, but we wanted to run it at a scale. So we are hoping ECS will provide that out of the box for tagging at the container level. Yes.
Have you guys leveraged any network vendor, like DNFs, or have you been mostly concerned with how to put together, offer these various templates and stuff for the environment for your developers? So like for security purposes or networking purposes, are you hosting those type of containers from network like vendors at all, or are you just taking what Amazon is providing and just leveraging whatever they're providing?
So for the network, as I mentioned earlier, we have load balancers that we use, and the protection that we provide two layers, right? One, use security groups to provide that isolation, and then we have a vault as well to do some kind of service application level security, but for most part it is just leveraging security groups. We don't have any third party integration with networks. Yes.
Do you have any challenges with underutilization of resources? So,
All the time.
yeah. What are your tools?
So at our scale, honestly, we can't. Like when I say scale, not about the clusters that we are running, but the number of people that we interact with. Right? Like it's not one central team's responsibility to have that like better utilization of the resources. What we do at the cluster level, we try to cram as much as we can, because earlier we chose C4, some R3 instance type. Then we saw that the CPU to memory ratio was very, like memory was consumed more and CPU was consumed very less. So then we flipped around, now we are using like C4. So that level of monitoring and feedback that we are adding into our clusters. But at the container level, it is actually up to the teams to manage that and make sure that they are performing optimally. And that goes back to the question that was asked earlier, if we can go show that charge back or show back at the container level. And at that time, it is a responsibility, pure responsibility of the applications to make sure that they are running efficiently. We can't go and talk to 2,000 people to say that, hey, you need to optimize, you can do this, you can do that. So that's the thing that we have.
What about not just at the compute or memory or whatever level, but what about spinning down resources that aren't being used at night, let's say in the wee hours in the morning, and then spinning them back up. Do you have?
So we have those automation already.
Do you have that in place?
So today we look at 24 hours. If you didn't receive any traffic within the last 24 hours, we basically delete your ECS service. So it's a continuous thing that runs all the time.
That's made it a test environment.
Yes.
Do you have any way to throttle a container or detect a failure loop?
So one of the throttling mechanisms that we built into our automation, like earlier Suresh was showing that script, right? When a new app gets deployed ECS, they only get 1/8 of a CPU, and they only get 1.5 gigs of memory. And that's the level of throttling you start with. But if you want, you can bump it up. But again, there is a max threshold where you can't go beyond like 8 GB or some other number for CPU. So we do those kind of throttling, but not of number of memory.
So it would be a crash, a failure loop inside of the container?
That is determined by, like not by us, like when you say max CPU, sorry, max memory, Docker is looking at that, hey, how much is your consumption? If you are beyond that max setting that you asked me, I'm going to kill it. So that part Docker takes care. And then with us using ECS, like a closed loop, ECS says, hey, you asked me to run 10 containers, I'm going to spin up this destroyed container and trying to bring back. So that part of handled by ECS itself. Our job is to throttle because of the resources that we can actually set up across the clusters.
Cool. All right. Thank you for all the questions, and thank you, Kuldeep and Suresh. We'll take a few minutes to Polyverse, talking about dynamic security. All yours.
All right, can you guys hear me?
No.
All right. I have very bad hearing, so if you say something, I probably can't hear you, but we'll work on it. All right, so Polyverse. We are a software security company, and we do software in a non-traditional way. So I'll dive right into what that means right after I tell you about a little bit about our team. So our CEO is Alex Gutierrez. He was CTO of AOL, CTO of Microsoft Online, Bill Gates' technology advisor for many years. And our VP of engineering is Chris Hanaoka. He was GM of cloud infrastructure at Microsoft, so Azure, and VP of engineering at Ask and Yahoo. And there's Archis Gore, who's sitting right back there in the middle next to the guy in the t-shirt with the hat. He will answer all your questions. He's our CTO. And he ran Amazon's site reliability and uptime for Amazon.com search. And so they're very familiar with security, DevOps, and all those different types of craziness that have to go on. So, who am I? Why am I standing here? They get me off the street. They pay me in food. So no. So I'm Kylie Williams. I am a security architect for Polyverse, and historically I've been a full stack developer for about 21 years, and I started when I was 8. So that's right. So and you're getting to that too. So. Previously, I was the CTO of a software company that I started and sold to a company here in Seattle. Alex Gutierrez, our CEO, has been my advisor since I was a PM at Microsoft in 2007. And so, as he did with most of our team, he pulled all of us together and said, "Hey, let's get a really solid team together to make this product work." And so, if you have any questions, just feel free to hold them. We'll have a bunch of question and answer at the end. Archis is your guy for most answers. And if you can't hear me or you need me to repeat something, let me know as well. So the traditional way of security. So typically it's a lockdown heavy process. It's a lot of complexity. People think the more complex something is, the more secure something will be. They think that if you have 5 locks on the door, that you can't just kick in the wall next to it, right? So that's that's something that's a misconception in software development, software engineering. And then you have on the other side, the business side, who's saying, you have a CEO that never says, hey, can you move a little slower? They're always like, can you move faster? Let's be secure. Let's be more secure and move faster. And so that happens a lot. I'm sure a lot of you are familiar with it. So that being said, security teams, they look at themselves as the guys on the left there and just hanging out and securing everything. On the right, when anyone asks anything of a DevOps team or a developer, operations person, we can do it. Can you make it float in the sky and go to Mars in 2 days? Yes, we can do it. All right, so in reality, what happens is you get this. You get security teams that are saying no to it. And we get this guy on the left here. And you just end up saying, you know what, I don't care about rules, open all the ports, let everyone in, I don't care. And this is actually, I used to run hurdles in college, and this is the funniest thing I've ever seen. So we came up with the idea of DevSecOps at Polyverse, and I'm going to read this off the screen here. Maintaining high security of the system as a whole, with the acknowledgement that individually secure elements as well as security components can and will fail. And a lot of it really comes down to everyone needs to be responsible for security. It's not just, oh, let's build all this stuff and then hand it to security people, because you get that picture above. You don't get anything out ever, and everyone's pissed off at everyone else, and fingers get pointed and that kind of thing. The other big thing is a lot of people, security just, it gets in the way, right? Someone says, all right, we need to have 4 passwords to get to this one step, and someone's like, I just want them to download Java. That's all I want. But instead they got to sign up and they got to make sure this and that. It needs to be operationally viable. And that way, you can get at the end of the day, you're building something. Most things are not built for charity. You're built for getting something done and making some money, right? And so, or making some, increasing something somewhere. And so that's also where we started talking about agile security. You've got agile development within security, it gets to the security part, and then it's like, oh, it's stuck in security, it's stuck in compliance for 6 months, right? And by the time that 6 months is up, you're already behind the competitor, you're already behind who you want to catch up to or who you wanted to beat in the first place. So agile security is something that we've started pushing. We've got a few documents and blogs coming out about it, if you want to read about it, and talking about how to combine development, operations with security so that they're all working together. And it's the responsibility of everyone in the organization to be secure. Some of you probably went to Black Hat and DEF CON. There was a guy who was sitting up in a tree outside of Caesar's Palace for a day and a half, camping there, hanging out, and watching people go in and out. Right? And he was able to get into Caesars and basically, as you would in an attack or in a software system, walk through the entire place, make his own badge, get replacement badges for his friends. And they were just hanging out in there. And I met one of the guys who was telling me about that. It was like 2 in the morning, he showed me the badge, and was like, I'm going home and not using internet. So, and so that, if those people who were walking in and out of the door, they were just the people who were, the food service workers. They need to be responsible for security as well. Make sure, no one's walking in behind you. Make sure you're alert, right? Everyone has a responsibility to maintain everything and keep everything secure. So ultimately, if the company gets hit, Caesars gets hit for $1 billion, $3 billion loss, those food service workers might get laid off, right? So there's a lot of things like that happen that affect the entire organization. So today's world of security. Right now, the number of attacks obviously is spreading. We get more devices out there, cars are connected, lots of connected devices everywhere. And that's becoming, it's great, but it's also a problem. The more convenience you have, the less security you have, right? So, almost everything is connected. And so if you look at any person right now, I don't have a smartwatch on, but most people do, right? And so that means there's generally something connected on everyone. And so right now, according to the FBI, 2016 saw a rise of 24%. And that's in the reported numbers, and 1.3 billion in reported. There's a lot of people who can't report what they're losing, and there's a lot of people who don't want to report what they're losing. I heard some HIPAA compliance and PCI compliance questions earlier, and you get hit with one PCI compliance issue, that could multiply pretty quickly and shut down your business, right? So we'll talk about how we approach that at Polyverse as well. We approach defense at Polyverse for that. So do we have any security experts in here? Raise your hand. Anyone? All right. Come up, I'm kidding. All right. So what's an attack? And so during this talk, I want to make sure that we understand what security is, what it means to be secure. And so at the end of this, if you have questions, what we're talking about, what is this, define that. Especially if I talk about something that isn't defined on here, please throw an error, segfault, something at me and tell me that it's not defined, and I will define it. So what's an attack? An attack is when data is modified, stolen, or held ransom. A lot of that stuff, ransomware has been huge lately. So it's unauthorized access, that's either digital or physical. Again, the same guy who was telling me his buddy was up in a tree and then all this other stuff, one of the 3-letter agencies asked him to, it's called red teaming. They hire hackers to go in and do stuff. they asked them to break into one of their servers, and it was really secure software-wise. But then he realized, oh, they have a regular key and lock on the door. He picked the lock, went in, and stole the server. So that's so there's a lot of things there that you have to think about. Unauthorized access can be digital or physical. When systems are adversely affected, someone might break into something and not really change much of anything, but you might, try to take a penny or less than a penny, here and there, and it ends up shutting down the whole business. That was a movie reference. And then resources are used by unauthorized partners, or student parties, and that's huge, right? You don't want someone, going in, think about a car, right? You've got a fleet of vans or whatever, they go and steal your van and, do their work for the day, and that's, they're using your money and making money for themselves and that kind of thing. So these are just basic attacks. Terminology, let's define some things before we get deeper. Vulnerability. So we'll talk about vulnerabilities, exploits. A lot of people will talk about, a vulnerability and an exploit as if they're the same thing. And a vulnerability is required for there to be an exploit. You have to exploit some vulnerability somewhere. And that's also attacking someone's vulnerabilities, right? So the biggest one is human oversight. Again, like I said, Caesar's Palace, the people at the three-letter agency where they just, the door was a lock and key. The next one is some tactical or logical bugs in code. A lot of us don't sleep very much, and that turns into code being a problem, or your code having problems in it that let things, you miss things, you miss checks here and there, and that's how you end up with a lot of buffer overflows and buffer overruns in code. And I'll touch on that. We'll get into buffer overflows and buffer overruns. And I'm sure the developers in here have seen that and have gotten errors like that in your code. The next step is exploits and attacks. You get code and script injection. A lot of the most popular ones are SQL injections. That's really protected nowadays, but back in the day you had LinkedIn, Facebook. There was a lot of different major companies you could do SQL injection attacks on and do lots of different things. My LinkedIn name actually was just changed. I had an exclamation point in it, and I used an attack in 2007 to put an exclamation point in my name and color it orange. And so they changed it orange, and they finally changed the exclamation point. But that's something that, simple things like that. Some people do things for fun, they might have left it in there for a game or whatever, but some people do some nasty things. You can edit, you can change database roles, you can add money. I used to host war games, and we used to have a bank as a war game, as a test bank. And the goal was to move everyone's funds into your wallet, and that's something you can do with SQL injection attacks. And so again, that's something that we can talk about if you have questions. There's jump-oriented programming and return-oriented programming attacks, and viruses and worms, which leverage all of this stuff above to worm their way through systems and to move code around and to do specific malicious things. So the last thing that we'll talk a lot about, or the last two things, a 0-day or a 0-hour or 0-O day, as I call it, attack or vulnerability. You have 0-day vulnerabilities, and then you've got 0-day exploits. The 0-day vulnerability is something that's a vulnerability that was found, and it's there, and almost no one knows about it. It's on the 0 day. So think ground zero or patient zero. No one really knows about it. And those are things where you'll see Microsoft or someone publishes something and they go crazy, right? The 0-day exploit is now someone's figured out how to exploit that vulnerability. Just because a vulnerability is there doesn't mean someone can actually exploit it, right? So. And that's kind of what people go after, are those 0-day exploits. Lastly is advanced persistent threat, APT. That's the way that attacks work, and we'll talk about that shortly. But that's basically a threat that builds upon other exploited vulnerabilities that are found. So what are the numbers around it? 65% of all the CVs in 2017 were related to crafted attack vulnerabilities, which are, again, we have one that we'll show, but those are things like the return-oriented programming, ROP, and JOP attacks. That's 65% of what's out there right now. There have been 39 since June 1st of this year, and those are things that are pretty much unprotected right now, and that's a major issue. And so that's something that we keep in mind when we're building our software. And again, we'll touch on how we prevent that proactively. So the anatomy of an attack. The Hollywood style is a myth. There's no matrix. You can probably build a really big script that does lots of things, but those are the worms and viruses you see that took a lot of people a lot of time to build, and really smart people to build that, right? And that's how a worm really works, but it's doing a lot of things. It's really a really complex software program. Realistic attacks are time-consuming, multi-staged, and they leverage a variety of attack vectors. An attack vector, obviously, is just something that, a way that you can attack a system. That's just think of it that way. And so you want to reduce the attack vectors, the space that you have, that someone has, that someone is able to attack on your system. And that way, think about when you're sword fighting, for example, right? You want to turn sideways so that they have less to hit versus facing this way. So, how does an attack work? They start by fingerprinting. And you identify the operating system, you identify the application stack. And then you identify the vulnerabilities in those stacks. The reason why you're able to do this is because you can go to any application, you can go to any application stack and go download that same code from the provider of that code. So let's say you're running PHP 5.4.2. That might be off, I can't remember what version it's at, right? But PHP 5.4.2. That same version is going to be available on PHP.net. And then if an attacker sees that you're running that, that same version is also going to be available on PHP.net. And so they can go and rebuild an entire replica of your system and then go practice against it. I think that was Ocean's 13, the whole premise of that movie. They built a whole replica of the vault and then went and practiced for days and weeks and hours. And then all of a sudden, they got in, right? And then they had to just go do the same attack and then get in there. That's exactly what happens in the real world. And so the ways that people can find these vulnerabilities, you can search common vulnerability databases, or you can buy or trade them on the dark web. And so there's a lot of the dark web. I mean, I'm not sure how many people really are on it, but there's IRC rooms that are out there that you can just walk in if you've got certain credibility. You can just say, hey, I've known you for this amount of time. I need this X, Y, Z. I've sat there, when I started when I was 8. I sat there and saw these things going on in other languages and things flying left and right. And so it's out there. Now it's more expensive, but again, back in the day, it was really easy to get your hands on some really nasty stuff. Now, again, if you've got the right network, you can go out and get that for 10 grand, right? And if you can buy something for 10 grand that's going to yield you $1 million, someone's going to go buy it, right? So those are things that, again, those are the CDEs that I was talking about on the last slide, and that's kind of what you want to watch out for. The last thing is replicating the environment for test attacks like I was talking about. They download and set up the same stack, and they recreate the whole application in its entirety. That's actually how I learned how to code, and I was part of a white hat hacker group, and I learned how to code. I was the replica guy. I go look at a website, and I was really good at figuring out how the website is built. And then I go build it, we find the vulnerabilities, and then go tell them and reveal it to the company. And generally they didn't like us because we were too young, but they fixed them anyway. So, but that's, a lot of people will do that, and they'll do malicious things to it, right? So let's go over a quick buffer overrun, and that way we can frame the conversation for where we're going next. So let's say you have an 8-character field that just takes in a name, right? So the question is, all right, cool, we can put in 8 characters. What happens if we put in 9 characters? The program shouldn't allow it, obviously. The underlying platform may be flawed though, right? So you might say, hey, I'm going to check and make sure this amount doesn't get in. But your platform that you're building on was built by a programmer who probably didn't sleep the night before he released the code, right? So there's all kinds of flaws that are beneath the hood that you have no control over, and you have no idea what can happen. So let's say 8 characters are inserted. That looks good. But all of a sudden you got 10 characters that were inserted. And let's say either you forgot to check or the underlying check is messed up. Then all of a sudden, what's called an overrun is that this just overran the memory. This down here is the memory that is set aside, allocated to contain that string, that 8-character string. But now you've got 10 and it's overrun. So what can happen over here in the red, is actually kind of scary. So they can an attacker can insert instructions if that space is large enough. Now this goes back to you've built a replica of the system that you're trying to attack. And so now you've practiced enough and found those spots in the system that are large enough to insert an instruction of your liking. And so let's assume that you have a 2-character instruction that you want to insert, right? We'll call it go, right? And so you want to say go, right? And that instruction, you can now point to other locations in memory to run other programs in memory. So now you've written over memory that already existed. You inserted your own instruction, and you said instead of going to close program, go to run more stuff. All of a sudden, run more stuff, you inserted a file. This is an advanced persistent attack that I just mentioned earlier. You've already put some stuff in there that now that instruction is pointing to run this zip file that I just uploaded, and which is a massive zip file because there was another vulnerability that allowed a 2 gig file to be uploaded. And so that's what happens when attackers are able to do buffer overruns or buffer overflows. Oftentimes they can run privileged commands as root, and typically what you'll see is they'll actually run a command and then create a user so they look like they're supposed to be on the system. And so now you've got a user on there, you're like, oh, system H, is that a new thing that I should, okay, let's not delete that, but it's really a very malicious user that has root access to do whatever they want and they're running around your system. And so that's kind of what happens. So what does it mean for the victim? Lots of bad things. I'm sure you can imagine in your mind. Money issues, you've got data leaking, you've got all kinds of things, right? So, so what do one of these look like? A modern crafted attack typically tries to hide itself and look like it's part of the system that is already running. It tries to look like it's supposed to be there. And so now that's why traditional defenses are bypassed, and again, I'll touch on that in a bit. But if you look at something and you say, oh, that's how it's supposed to act, and it's supposed to run, and it's supposed to point to other instructions, I don't know what instructions it's supposed to point to, but it's supposed to point to other instructions. So as long as it's pointing to other instructions and not crashing, we're all good. So you've now tricked the traditional defenses that have been set up to detect that, and now you're scot-free. You can go right up in there and do whatever you want. But this requires detailed knowledge of the target. Like I said though, if you have all the time in the world and you're downloading the same thing that everyone else is downloading, and it's always going to be the same, if you got that bolt, you can do whatever you want, then you're going to get in eventually. So what are we looking at here? This is a crafted attack built by one of our engineers, and this is going to exploit a vulnerable Java plugin. Vulnerable Java plugin, and what it's going to do first is this first part is overrunning the, it's doing a buffer overrun. So let's assume there's 30 something bytes that you get to overrun, and it, you put in a bunch of data there and it overruns it. So after that, you use something called a ROP gadget, and that's something that's in the program that you've identified earlier. There's tons that are identified as an area, like I said, an area that you can enter an instruction that can point to where you want to point to. And then you tell it what you want to point to and what program you want to run. And so this is base64 encoded ROP gadget, or excuse me, base64 encoded crafted attack using a ROP gadget that will give you root shell access if you're running that Java plugin. And so that right there works. It's something that works, but it's very specific to a very specific thing. But there are lots of those out there. This is what you would find a little bit more complex, a lot more complex to pay that 10 grand, 20 grand for to break into something. And so again, if there was something that I lost you on, let me know. But try to go a little bit slower here so we can make sure we get the problem framed. So why is it possible? This is my bedroom as a 16-year-old, and I would dumpster dive whenever I needed a new server to build as a replica. And as a 16-year-old, I had all kinds of things running on here that could replicate what real production systems were doing, right? It's a lot harder nowadays, but 16-year-olds have AWS now. They can do the same thing, right? So, so this is, it's totally possible. It's, again, 16-year-olds have a lot more time than we do, right? So they have a lot more energy and put a lot more effort into figuring out how to get into something. You've only got to figure out how to get in once. Once you're in, then once you figure out one way to break it, it can run everywhere that you've built that replica for. So let's visualize how this works. So what we're looking at here is a multi-stage attack that you can see the attacks growing. As you break into one piece, you try to move through the system. Now, typically in the industry average, people do not reset their systems. Imagine not restarting your computer for 230 days. I walked in here and my computer was frozen. I had to restart it. So a server that's sitting there for 230 days untouched, this is what happens. Attackers have timed the cameras each tier that they break into. And then they leave backdoors as shortcuts. They go get pizza and hang out and go party and come back, and they walk in again and they're just like, hey, let me just get back to where I started off again. And because you haven't reset your system, you can pick right back up, or they can pick right back up where they left off. And so as you see, this is moving. You're already infected over here. Your edge, you're getting defaced. They can put up whatever they want. Your middle tier can have all types of things, right? But they're running around testing things. This might be your local network or your corporate network. And you've got your microservices. Now they're in your microservices. Your code, you have no idea what code is good, what code is bad. And now they're in storage. You're accessing all of your insurance records, everything that you need that's valuable to your business. They're accessing, copying it, selling it, doing whatever they want with it. Or they're doing other malicious things with it, or to the people that own it. And so this is something that we're very adamant about. This happens every day. This is how many of the large corporate attacks that I won't name have happened over the past year or 2 years. People get in, they sit there, and that's what they do. They run around. So now, why are traditional defenses insufficient against attacks that look like that? Well, one, a firewall. The firewall lives on the edge there. The firewall lives on the edge there. And once you're through that firewall, you can have fun. You're home free, right? So the next thing is antivirus. I explained how you can trick antivirus into thinking you're doing the right thing, into thinking that you're doing something that's supposed to happen, right? And so that's the next thing is antivirus. Now down here, I put a star next to them. The tools that detect or highlight attacks after they've happened. That's great that you told me I got hacked, but I didn't want to get hacked, right? And so let's try to prevent that before it happens. And so log analytics, patching, and antivirus. Antivirus is kind of on the fence there, right? It can stop a lot of things, but it can also tell you that something's wrong. So patching, again, a 0-day comes out, and I asked a very large hosting company in the Midwest, and I said, what do you do when a 0-day comes out? And they say, well, we hope they fix it quickly and release a patch. And so I'm like, so what's happening? Why are you guys getting hacked? It's like, we're hoping that they're not hacking us. And so, again, that's something that we can prevent, that what we built can prevent, and we'll touch on that as well. So these attacks, they do get through, especially the manually crafted ones, because again, you've got someone sitting there for hours at a time just hanging out and trying to break into a system that they know has a vulnerability, right? And that's how you get things like WannaCry, and that's where the 0 days come from. So how can we stay safe? That's what I do very much. And that means I need to restart my machine.
You got We went through all the craziness. Oh, wow. So how can we stay safe is what I was talking about. So we can either let things stay on fire, or we can employ what we call moving target defense. And moving target defense is all about changing the attack surface under the feet of the attacker. And so one thing I like to joke about, Russell Wilson figured that out the hard way. Moving target defense, what it does is create dynamic diversity in every system that we come in touch with. It foils crafted attacks, it derails advanced persistent threats, and like I said, it forms a constantly shifting attack surface under the feet of the attacker so that they can never get a proper foothold and build those advanced persistent threats that we talked about. Now that astronomically increases the cost of the attack for attackers, which is actually the point of defense. If you can make it too expensive for them to care about you, they'll move on to the next phase, to the next person. So back to this slide here. What happens if it resets frequently? And what if attackers only have a few seconds to get a foothold? And what if memory layouts change beneath their feet? And then what if every binary that you installed was unique? And so that's what we do at Polyverse. And that's the products that we put out. One of our products is goal-seeking container solutions, which is really relevant to Docker, right? It's really important that you build your applications with a microservice architecture that can be reset in a way that is not going to it's not going to cause you to have to restart and have a whole bunch of downtime and that kind of thing. We constantly reset to the known good state of your system. And that known good state basically is what your system should look like. You know the size of your containers. You know what good means, what good looks like. That's why I use Fry up there. When you look at something and you're like, hey, wait a minute, this doesn't seem right, then restart it or push it over to a detonation chamber. Again, we can talk about that in a minute. Any deviations should be flagged, and you should know about that, you should hear about that. And what does this mean for the attacker, and what does it mean for the victim? It means that the attacker now has a much harder job, and the victim can be more relaxed about what they're doing, and you're able to always reset to the last known good state of your system. Unfortunately, it didn't work on my laptop, but it's dead, so it's fine. So the goal is to seek. An example would be in request per container. If you want a certain amount of requests and want to kill that container, then that's something that's a goal that you want to strive for. Container lifetime, keeping your containers up for less than 230 days. Keeping your containers up for a maximum of 20 seconds and restarting them. That right there, again, will give you that constantly refreshing, resetting back to the last known good state. session isolation, inline request validation, and need-to-know access to data on the system. So right now, database admins have access to an entire database. They don't need to know every row and record in that database. They need to know that it works, that it's up, and that the correct people are getting the correct information. So again, that's what we do at Polyverse. We have a container cycler solution, and our container cycler solution really is a goal-seeking solution that I'll touch on that in just a second, actually. So, and then we have a full suite of products, including polymorphic Linux, binary scrambling, and a whole host of other things that I just touched on that get you to the goals that you seek. And so the compiler-based binary scrambling, this is at the compiler level. And at the compiler level, what we do is we move around machine code, we move around functions, we move around memory registers that are being used. And unlike ASLR, it's not something that we move one pointer and you can, once you figure out where one spot is, you find all the other spots. This is constantly shifting, constantly changing. Again, the attack surface is always moving. And so if you go back to the image I had up there of the container cycler scrambling and moving and constantly moving and keeping the red out of becoming large bubbles, that's what's happening here. Every time that you cycle, you get a new binary installed. You get a new binary scrambled, and that way you're moving around the places that a crafted attack knows where to attack. And so the prime example that I showed, where you had that attack, it knew where to place the instruction in memory, and it knew where it was going to land and how to open that shell. You now no longer have the ability to do that. The odds of that are 8 times 10 to the negative 17. And so that's your probability, excuse me. And that the probability of getting the exact same unique scramble. And so that's going to be highly unlikely, especially if you're continuing to cycle, let's say, every 10 seconds. And so you have an extremely difficult time getting into where you want to get into. You likely have to find another way in. And so the next step, like I said, is goal-seeking container cycling. Again, this is the goal here is that you want to keep your container cycler up for a maximum of X seconds. You want to, another really interesting use case is my container has grown to 100 megabytes, right? And you know it's supposed to be 30 megabytes. Something's wrong in there. Whether it's bad code or whether it's something malicious, something's wrong. Reset it, refresh it, or stick it over into a detonation chamber and let the person think that they're breaking into something and doing stuff, but they're not. You're just learning what they're doing so you can protect against it next time. And so that's a huge, these two products are our flagship products, and that's our polymorphic Linux and the binary scrambling. We really make sure that it's extremely easy to use. It stays out of your way, and it's actually one line. That one line of configuration down there is all you need to do. And so moving forward, where has this been used? Right now, we've got a lot of larger customers. The first, or one of the largest, or the largest customer is a name that we can't name, but we can talk about it. Over 500,000 lines of code, probably over 1 million, and over 70 developers, over 100 servers. And this is something that is an application that's constantly moving. It's using old and new platforms. It's actually it's a cutting edge application, but it's something that you see in movies, right? And it took 23 lines of code. It's less than 20 seconds, 23 lines of code to modify and configure it to work with Polyverse. Less than 20 milliseconds of latency, and it took less than a day to install. And it's been running without any breaches. And actually, anyone that's been using our Polyverse products have not had any breaches with crafted attacks and what they're looking for, and since we've deployed on them. So that's a case study. Our proof really is in the pudding here. It's we love people who are red teamers, and like I said earlier, those are people who are hired to break into things. They're hired to do bad things, and so that's something that we always want to keep trying and circulate what we're doing here. And everything that I showed you is very simply implemented with our Polyverse solutions. That's the whole goal. Archis back there has spent a lot of time deploying things and having a headache around things and saying, I don't want this to be in my way, I just want it to work. So if you're a DevOps person, you just want something to work, that's where we kind of come in and say, just try it. And so we've got a lot of people, Jason Yordi, and Jason Yordi's a former DoD scary person that I don't want to meet in person. And so, so that's kind of where we land. You can go to polyverse.io, give it a try. You can go to try.polyverse.io, and we're constantly evolving that, so you can get a quick test and just try it. That's kind of our goal, is we just want you to try and give us feedback. If it's easy to use and you want to see more, then let us know, right? Shoot me an email, shoot me a text, whatever you want. Now the big thing is, for anyone who's using our scrambled binaries, we're entering them into a $200 Amazon gift card. So I'm going to try to enter it in that channel. So just tweak and just follow the instructions there. Also, we've got cybersecurity superhero capes, which people seem to love. We'll give out if you blog, and mugs, massive mugs and chalices for however much late nights you have. So, any questions you have, let me know. Any questions about security in general, or just trying to figure out and learn about more about Polyverse and security, that's what we're here for. So, apologies for the hiccup there.
Two real quick questions.
Yep.
Polymorphic Linux, is it only on CentOS or do you support other OS?
We have Alpine, Ubuntu, and CentOS.
The second one is the binary scramble computer. Does that only happen after linking, or does it happen every time you load?
That happens at the compiler level? Or you're asking like in the compiler?
Right. When you scramble,
Yeah.
do you scramble it when you compile, when you link it, and every time you run it's at the same locations, or is it re-scramble every time you run it?
It's not scrambled every time you run. It's only scrambled on compile time. That's Steve. Steve could probably answer more about what we're doing in terms of the future of having things scrambled as we run it, but right now it's not scrambled.
The quick answer is we build many times with randomization built into the compilation.
Yeah.
So you get many binaries. You can choose to have one, or you can keep running different ones, or you can rotate through them however you want.
Okay.
And the idea is that each binary is different enough that it breaks these crafted attacks. Because they know how the attacker doesn't have the same bits that you don't have the same bits that the attacker had when they crafted the attack.
All right, thank you.
Any other questions?
How can you test an application that's scrambled?
So and that's kind of one of the things we like to show in demos is it's really up to the developer or the ops team or whoever has those requirements, right? It's when we do tests or people want to do proof of concept and that kind of thing, it's, hey, tell us what your test cases are. And you have test cases, you have test suites, and they should run the exact same. When we test our stuff, Java has all the same issues that the Java that you download from Oracle has. They have a lot of compliance issues, whatever it is, but when you test, it should come out the exact same. If you had problems before with unscrambled versions, it should come out the exact same.
Sorry, I was wondering if there's like a test suite or some sort of a test suite, something that can test for vulnerabilities or random exploits and things like that.
So right now, that's something in terms of that that takes manpower that we don't have right now, but that's something we're working on. We're coming up with some testable exploits for vulnerabilities. But it's also a shady area.
Yeah, one of the big challenges for that is if we actually did come up with an exploit, it would be a weaponized exploit. So it would be a real 0-day that would actually take over Java, right? And so it's a bit of a slippery slope for us to have it in our possession, just legally and in many different aspects.
Yeah, but no, also, so we use the technique which is kind of, we invent fake vulnerabilities. I mean, we commit them intentionally, so we can actually show how they can be exploited, and then we can apply scrambled binary and show it doesn't log anymore, right? So this is kind of in the middle solution which shows that the approach works. Right? If this was real, defense would work also.
Illustration.
Yeah.
Without getting in legal hot water.
Cybersecurity is a questionable area, right? So you have to know how to play offense and play defense. So any other questions on cybersecurity or Polyverse?
Can you do Ubuntu as well, right? And there's something.
What do you say?
Can you use Ubuntu as well?
Yeah.
So how far back do you go? Like 14 or 16 or 17? What version of it?
So Ubuntu, I believe, what version are we on right now? That we support. So the Ubuntu supports
16.04.
What is it?
The 16.04.
16.04.
The LTS.
The LTS one? Or
Yeah.
You're always on the long-term support one?
That's currently it. We can do any of them. It's just a matter of where's the demand.
Yeah, it's against manpower, and we have a team of like 19 people. So.
And how frequently do you maintain those
It's-
mirrors?
It's every day-ish, and then so if we try to see it as frequent as possible, we see a
No.
change, and
If you mean patches, we track the Git
Oh,
repo
for
heads.
okay, sorry.
Yeah, so we track the release heads from all the Git repos that everyone's doing, and so we have a build farm that we notice a change, we rebuild it. So a few minutes at most.
Cool. I think there was a question back.
Yeah, I wasn't sure who.
Can it run on a small device?
Can you run?
Can it run on a small device?
If it's running this, like if you're running, an IoT device or something like that, yeah. If you're running CentOS or Ubuntu, anything that we support, then it'll work there. And then the same thing with the if you can run Docker on it, we're fully supportive of Docker Storm. We work really hand in hand with the Docker team. So there's another thing on the competitor out there with CertDK we'll talk about, but. So yeah, anything that supports the, if you can run it, as long as you can run it, then we can support it, so.
Do you have a plan to make it run on those big provider?
Could you repeat
Do you have plans to run it on a cloud provider or supporting on AWS? Is that the question?
So AWS again, if you're so that's a yes. If you're running again the platforms that you support on AWS, then that's something that we support. But if Elastic Beanstalk, we've worked with that. We've got some AMIs out there. Again, that's just getting started. But where the demand is, if someone shows us a lot of demand, then that's something we'll attack. So we have one up here first.
Yeah, so for user level, basically you do this binary straddle, right? But if I have reading 0, I'm going to go basically on kernel level. Can you do anything about this?
On the kernel level?
Yeah.
Can you
so
repeat the question, just because people aren't hearing it?
Okay, so you asked at the kernel level can we do anything about vulnerabilities or any vulnerabilities on the kernel level?
Read 0.
Yeah, range 0. So Steve.
We aren't yet. There's a lot more testing to involve with scrambling a kernel. So it's not done lightly, but yes, that's that's our part of our roadmap.
So it falls on him.
Yes.
So there's a GCC component which you use to compile the pieces that make up your application, and there's also a host component.
So yeah, so there's the two. You're asking like different.
Like the part that's gonna whatever system's gonna host your containers.
Yeah.
You would have components on there, and then you would also, whatever you got, Mongo, Node.js, this or that, also just compile it with Polyverse.
Right. Yeah. So you would point and the way it works really is points to your standard repository and adds to just points to our.
I understand it kind of integrates with your build process.
Yeah. So yeah, and that's it gets out of the way of it just adds those 2 lines to your let's say Etsy host or whatever, right? Or Etsy your API host. And so that was a big one, but your host file for your repo. And so the container, we don't scramble Docker right now, and that's kind of a common question. So if you're running Docker, that's not scrambled currently. But
the app on Docker
the app does not. I mean, so that's kind of so the first question is, or the first answer is for the scrambled binaries, like those don't require Docker at all. Those are just a repository. Now our Docker and Docker container cycler, that's all Docker. So Docker itself is not scrambled, but that's something we're working with the Docker team to secure kind of that overall host of Docker.
But you can run scrambled binaries in a container.
Right.
Just you're orchestrating it.
Mm-hmm.
Yes.
Yeah.
Another question about your repo. So we probably make, I'm just in dev alone, it might be maybe 100 or so Docker build per day.
Mm-hmm.
And so they're always pulling from the repositories to get the packages.
Mm-hmm.
Your handle that?
Yeah, we can have a massive build farm. I think it's called Big Bang or whatever it is. And so, and so, but you get 6,000, depending on your license, you get 6,000 packages per node. And
Packages?
yeah, so you're going to do each poll, you're going to get 6,000 polls, but you get 6,000 packages pulled down. So if you can pick and choose what you want to scramble. You can pick and choose to scramble your entire platform. It's up to you what you want to scramble. You can also do one poll and have a mirror and point to a mirror, right? But you're going to be less secure than if you have all your different
Same scramble binary.
Is what?
If I did that in mirror, then I get the same scramble binary.
across. Yeah, and so it's up to you. It's cost versus security.
I guess you could just do it for production ones, right?
Yeah. Yeah. 'Cause it's going to work the same, right? Your codes will work the same. So. Yeah.
Can you integrate with the CI/CD pipeline on Jenkins?
Yeah, and so it just falls right in, right? Because it's not going to interrupt that at all, because it's going to be using the same packages, it's going to look the same, except for your hashes are going to change because it is a different binary component. Yeah, that's the whole goal, is to get out of your way with that. So. Anything else?
All right, cool. Thank you. Thanks, folks, for sticking around. We'll get the next one scheduled in the next couple of weeks. Have a good night.